Hello everybody, how are you doing? Welcome to another revision live stream. So we're going to do something slightly different to start off with today. First of all, I just want to talk about a question that one of my students has sent me to look into, and I will cover that first. Hello everybody, how are you doing? And then after that, just hear me in the background where I can just test that the sound's working. And then after that, and after that, we're going to do paper 2 that we did the paper 1 in the previous sessions, and we're going to start looking at paper 2. But before that, we're going to have a look at the grading scheme and how that works, so that when you mark your own sort of stuff, you can work out what your grade is and what does it all mean, etc. Okay, so let's have a look at the question that one of my students sent, and here we go. Let me just transition it. There we go. It's been a week since I used OBS to stream. I can't remember what I'm doing. All right, so here's the question. This is from a past paper, and it's a truth table question, logic gates, and it says, consider the truth table here, and we've got that here. Draw a logic circuit to represent the given truth table, and each logic gate should have a maximum of 2 inputs. Do not simplify the logic circuit. So this is very similar to sort of the stuff that you will have done in the lessons with me, and we did cover this, but don't worry, it is quite rare for them to ask this type of question, but it's not unknown. Okay. So what do we do if we get a question like this? Well, what you have to do is you have to use that truth table to draw this. All we need to do is look at where there is a 1 in the output X column, because obviously that's our output. And we've only got 2. We've got this one here, and we've got this one at the bottom here. Ignore zeros, always ignore the zeros. Okay, so we can see that we've got 2 different rows here with inputs. And what we're going to do is we're going to write the logic statement based on the fact that we've got a 1 here and a 1 here. So let's take the first one. The first one, we've got A is 1, so we just put A. And we've also got B is 0, so that's not B. So not B. And we've also got, it keeps disappearing, and we've also got here, we've got C is 0, so not C. So whenever it's a 0, it's not what the input is, or notted, and then if we've got a 1, then it's just that input name. So that's our first row with a 1. Then we put an OR in the middle, and then we just take the next row, and that is A is 1, B is 1, and C is 1. So it's just A and B and C. So it's A and B and C. And that is our logic statement. Then we can use that logic statement to draw the circuit. So it is slightly different to what you might have done in previous lessons. We need to work out what the central gate is. So if you know, done my lessons, you'll know we've got this X here, this is our output, and we need to work out what is the central gate, because there's only ever one gate that goes out to that X. Well, we can see what the central gate is, because technically, actually, each row of these should be bracketed off. And all we do is we put the central gate. Who do you know? Which gate do you think is the central gate here? How do we know it's an AND? Oh, yeah, I'll just explain that in a moment, actually. Just tell me what the central gate is, and then I'll explain how do we know it's an AND. Because I started that question already. Yeah, so a couple of you said that it's the OR. Yeah, the OR isn't in any brackets. It's the central gate there. So we're going to put the OR here. So yeah, so someone's asked, how do we know that it's AND here? It's always going to be AND. So because if you think about the way that the truth table is written, it's A and B and C to produce this output. It's A and B and C to produce this output. So you always just put an and in between each one. And then if you've got, you would put or in the middle because it's another row. And then it would be not A, not B, and not C. So it's a set pattern. It's really quite formulaic actually, and is quite easy. Where do you get the or from? Yeah, because if you think about it, you're getting a 1 as the output. If this row is true coming in, so we've got 1, 0, 0, or if this row is true, a 1 and a 1 and a 1. So that's where we get the or from. Hope that's clear. So the pattern is, for all the inputs for each row, we put an and in between each one, and then for each in between each row, we put an or. Okay, so then we can just draw the rest of the logic circuit. We've got side 1 and side 2, side 1 and side 2 for the OR gate. So now this is slightly different because we've got two ands. And normally if you get a question, then it will bracket off and it's really clear. Now because these are all ands, it doesn't matter which ones you bracket off. So I'm just going to bracket off the first ones here and the first ones here. And then that means that this AND is our central gate, but ultimately it doesn't really matter. But this is our central gate here. That's an AND gate. I don't know why it keeps disappearing. So we've done this one and we've got not C. So I'm going to put a not here before it goes in. And then we've got side 2, we've got another AND gate, A and not B. So it's another AND. Oh, I wish it would stop doing that. So that's another and then we've got A and not B. And then on this side, we've got A and B. Oh, sorry, we've got this and is our central gate here. So that's our AND gate there. And coming into that is C. And then we've got A and B. So it's A and B coming into there. You don't like the single ones, the truth table to logic circuits. Yeah, I mean, just try and practice. Is especially if you're going to do A-level, because this comes up in A-level. Yeah, so it's always or as the central gate for these questions. Yeah, it would be actually. Yeah, it would be. Absolutely. Yeah. Because each side of these, that's one row. That was this row here. Or this row here is this side here. That makes sense. Can we try a single one? You need help with that. What do you mean? Explain that a bit more. You're very welcome. I'm glad it helped. Yeah. You're all my students, so well, I think most of you are. If you aren't, then if you are my student, you could ask. Do send a question and you think, oh, I can't work out how to do this, and I'll do it in the live stream. It's fine. And it's better to have specific questions rather than just sort of, can we cover this? Because we will cover everything because of the exam papers. But yeah. Can we try single logic gate? I don't know. What do you mean NSTY5PV? What? Just be more specific and tell me what you want me to cover. You mean, can we try single logic gates? So do you want to just like practice which logic gates are which, or like, so if I said to you, what is this logic gate and what is the truth table for the logic gate? Something like that. Yeah, okay, try this one then. What is the output for this? What is the gate and what is the output for X for this single logic gate? Yeah, good. It's an XOR gate. Excellent. It's an XOR gate, exclusively OR. And the easy way to remember this is that if the inputs are the same, then the output is a 0. And if the inputs are different, then it's a 1. So in this case, these ones, it's the same. So it's a 0. They're different. It's a 1. Different, it's a 1. The same, it's a 0. Do you mean what each one? Yeah, no. Okay, yeah, no problem. That's fine. Okay, so yeah, I'm happy to cover other stuff, but try and be specific, because otherwise we'll just sort of end up with you know, just general stuff. It's better if it's specific things. Let's have a look at this though. This is the grading scheme for the exam paper that we did from the last session. So in the last exam session, we did this component here, component 1.1. So what does that mean? So basically it means, look, if you look at the exam papers, it will tell you the code of the exam. So for this one, we're about to do the companion second exam paper, and you can see here it's got 2.1 on it. So that's the code that you look for on your grade thresholds, and it's the same for the 0478 0981. So we're just about to do component 2.1, which means that there's 75 marks altogether, and if you want to get a 9 out of that single paper, then you need to get 58 marks. If you want an 8, it's 50, 42, etc. To get a 4, which is the sort of the bare minimum pass for, you know, getting into college and stuff like that, then it would be 19 out of 75. Now these grades here do change for each sitting, depending on how hard or easy the paper is. So do reference these. As a general rule, you can kind of say roughly what the grade would be. But obviously if you do a set of exam papers and you mark your paper, then it should give you an idea of what grade you've got. Once you've done 2 sets of papers, then you can look at the bottom grid here, and the bottom grid, it's got AX and AY. So in the summer papers, the UK is normally AX, and in the winter it's AY, but it doesn't matter. Basically just do any sort of component papers together and work out what your overall grade is. So 2 papers worth 75 marks. And here you do paper 1.1 and paper 2.1. And overall you would need 116 out of 150 to get a grade 9. And you need, for grade 4, 38, and for grade 7, 84. So that's a helpful thing to do. But again, you can do all the papers, but if you do 2 companion papers, then it will give you a good idea. For this spring exam, you're doing 1.1 and 2.1. I think so, but it doesn't really matter which one you do, as long as, I mean, you know, it will be the UK one, but it will be the AX component. So yeah, just keep an eye out. So don't think, oh, in this set, so you can see the difference here. The AX paper was the UK one, and you had to get 116 to get a 9. But if you took the AY one, which is in other parts of the world, you needed 126 to get a grade 9. So it does differ, and it is worth looking at the grading thresholds to figure out what your grade is. And all the downloads that I've got on my that I've given to you, all the grade thresholds should be there. If there is one missing, just drop me an email and I'll upload it, but they should all be there. And also I've also added the A to F grading system as well, and you'll find that the grade thresholds are there too. Any other questions on that before we start to have a look at component 2.1, where we need 58 marks to get a grade 9? Okay, so let's start looking at the next exam paper then. Yeah, it is 074. It's 074, it doesn't matter. It's paper, it's the companion one, as I said. So let's just dive right in, and we've got our first question. Tick one box to check, tick one box to complete the sentence, a validation check to make sure that an email address contains an @ sign. How do they give you your markings as letters or numbers? So someone's asked, how do you give their numbers as markers or letters? So it depends on which code you booked the exam under. If you booked it under 0478, which this exam paper has got the code there, it will be A star to F. And if you book it under 0984, then it will be 9 to 1. So you just need to be, it doesn't, I mean, if you're in the UK and you're not planning on imminently moving to a different country, then I would go for the 098, the 9 to 1 grading, because that's the standard in the UK now. I have had a few students who, like, they're either live in a different country than the UK, or they're in a country that doesn't really recognise or like the 9 to 1 grading system. And yeah, I had like one student who was just about to move to the UAE, and they decided to do the A star to F grading. So it's just entirely up to you. The way that they mark it, actually, I probably should have said this, sorry, previously. The way that they mark the exams, it doesn't matter which code at all. They mark all the exams for both codes. They decide what is the grade C or the grade 4. They decide what is the grade 7 and what is the grade A. And then everything else is kind of spread out in between that. So it literally does not matter which grading system you choose. There's no bias towards one or the other. Okay, sorry about that. I'll stop talking now. We can do this question. I think most of you have answered it. A validation check to make sure that an email address contains an @ sign is a format check. So yeah, I think most of you got that one right. Next question. We have got 4 descriptions of programming and 5 programming concepts. Draw one line. So always be careful when you're drawing lines. Check how many lines you need to draw. It's one line for each description to the most appropriate programming concept. And I will put this into the whiteboard, and then I'll put letters there for you. There we go. A, B, C, D, 1, 2, 3, 4, 5. Are you all doing mocks at an exam centre? Because it's actually not that long until you get my mocks either. In fact, they're straight after half term, so you get half term to revise. Okay, let's answer these. And so a subroutine that may not return a value is a procedure. A value that is declared and used within a specific procedure is a local variable. If you went to the Improve Your Python webinar that I did a couple of weeks ago, we covered local and global variables in that. If you want me to cover it now, I will, but I'll just finish off this question. A value that a procedure expects you to supply when it is called is a parameter. And then a subroutine that will always return a value is a function. Does anybody want me to go over this? Or any of these? Or all of it? I don't mind. Or we can just carry on. Yes, please. Can you cover the global and local variables? Yeah, okay. So just, I'll do all of it actually. Just a quick one. So if we look at the difference between procedures and functions. So procedure is exactly the same as a function, but it just doesn't return anything. So a procedure in Python would be something like print. It's just going off, it's going off and it's printing something and that's it. Whereas a function does actually return something. So a function would be in Python input, for example. And we use input because, I should use a darker colour. And we use input because we get the user input as a variable, and then we use input and it returns into that variable what the user typed in. Whereas here with the print, it doesn't do that. So that's the difference between the two. A parameter is obviously anything that we put in those brackets when we call it. So for input, we could put a prompt in there, enter your name or whatever it is. And for print, it's just whatever you want to print out. And that's the parameter. The parameters go in those brackets. Now, the difference between global and local variables, let's have a look at that. Because this is a little bit more complicated, but it's not too bad. Let's just go a little bit thicker. So local versus global variables. And this is something that is not just in Python, it's in all programming languages, and it is really important. So when you've kind of got to go back to thinking about when you declare your variables. So where are you declaring your variables? Where are you declaring your variables? So what I mean, we might have some code like, I don't know, a menu system to order food. Okay, so it's just a text-based one, old style, but it doesn't matter because it just proves a point. So we have our main code, or our code to write our menu system to order some food. And we might have here, I don't know, order number equals 0. So we start with 0, that's our order number. Or actually, probably we want to start with 1. That's probably more likely. We want to start with 1. And that order number can be seen by the whole of the code. So it's a global variable. So if you declare anything that the whole code can see, or whole of the main code can see. And I put C in brackets, in quotes, sorry. Now you might have, for example, a for loop. So I say for I in range 10 print something or other. That I there, that is a local variable, or it's an example of a local variable, and it's local because it's just used in this block of code and nowhere else. So if someone then tries to then down here say I equals I plus 1, you'll get an error because I will get destroyed by Python, or any programming language actually, in memory because it's not used anymore. And what local variables are good for is basically if you're trying to do something and you're using some data like this here in the loop, but then once you get to this line here, you don't need it anymore because it's just for that for loop. Then in the RAM where you created I, and I is storing a value or whatever it is, it will then get destroyed once it gets to this line here. Now, they're not going to ask you anything as complicated as this, but it is quite helpful to know what's going on inside the RAM. Whereas order number, because order number is a global variable, that still exists. And that still exists until you finish and stop running the program, you switch it off. Now you can have local variables not only in things like for loops, you can have them in if statements if you want to, if you're creating a new variable just for that if statement, but you can also have them in a procedure or function that you've defined. So if we define a function here, so I say my function and I create it here, and then I add some lines of code and I create a variable called x equals x plus 1 or something like that, then that x is only defined when we call that function. So x will only exist when that function is being called. It's a local variable. And basically, if you create a variable inside a function, it's always a local variable. So local variables are used for either blocks of code or in functions or procedures. Global variables are just anything that is available to the whole program in, that's the main code. Is the best way to improve coding for the exam just going over the webinars? Well, the improve your Python webinars are for improving your code past what we're doing in the exam. So not really. If you're just looking to pass the exam, then just going over the lessons would be a better approach. And practicing the questions as well as we do them here. You can also do in the Isaac computer science revision sessions. Yeah, they are still really good. If you just Google Isaac computer science, it's completely free. It's funded by the government, and they have drop-ins, don't they? Webinars as well. And yeah, it's there because the government want people to pass their exam. Any other questions on local and global variables? Really important programming concept, actually, because it can get you, if you know this, what I've just described, it makes you a much better programmer because you can get errors. If you try, for example, and you know that X is there, and then you're in the main part of the code and not the function, and you try to use X, and it will go, no, don't know what you're talking about, because it would have been destroyed. Let's look at the next question then. So next question is this one here. Write the pseudocode to use a procedure named average that passes the values 25 and 50 to the procedure. Now, most of you should know this one because this was in your end of year assessment. So try that question, see if you can work it out. I do use real exam papers to do, sorry, my cat just burst in, I had to shut the door. I do use real exam paper questions in your assessments. How do you mod a global variable in a function? Yeah, you can do that. You just put the word global in front of it. I'll come to that in a moment. When it says pseudocode, can you use Python or C? No, you must use pseudocode. And in fact, if you don't use pseudocode where they ask you and you put the most perfect Python, they will give you 0 marks because they made a few changes to the syllabus from 2023 and it's called the 2026 syllabus update. From this summer, if you don't use pseudocode, they will give you 0 marks. And that was one of there's about 4 changes, 4 or 5 changes, tiny changes, but that was a really biggie. Whereas before you could just get away with it. The exception is the 15-mark question. All right, so yeah, so good answer there. The answer is, if we look at the answer, because it won't let me write. There we go. It is call, because it's a procedure, we use call and then the name of the procedure and then the parameters. Good. So just going back to how do you modify a global variable in a function? Okay, so modifying a global variable in a function, you do this. So you have, for example, here's your code and you have, I don't know, x equals 0. And you have, actually, let me just write my procedure first. Or function def my proc equal, open close brackets. We're not going to pass anything in. We've got in our main code here, main code, we say x equals 0. What you can do is you can say global, use the keyword global x. And by putting that there, that's telling Python to use this main code variable, not anything that you create in your code. Now, I would shy away from doing this. When I found out, because I used to be a Java programmer and a C++ programmer, when I found out you could do this in Python, I was like, this is shockingly bad. You shouldn't be allowed to do it. You should pass it in as a variable. The best way to do it is to pass it in as a variable and then change it and then pass it out through a return. But because you shouldn't have functions changing things inside like that, it's just not good programming. You'll never have to use Python. There will never be a question that you have to use Python in. So there is the 15-mark question, and the 15-mark question you can use Python, you can use pseudocode, or you can use, there's 2 other languages that you can use. Python, I think it's Java, and I think it's VB.NET. So just a 15-mark question, yeah. But you don't have to. So literally you could pass the exam with a 9 without writing a single bit of Python, but you would have to write pseudocode. But in order to understand pseudocode, you need to get to grips with a programming language. Because otherwise you'll just find it absolutely, you just wouldn't get it. You just wouldn't get it. Okay, next question. Outline the role of procedures and functions in creating a program that is easier to maintain. And again, this was in your end of year assessment, so see if you can remember that. So outline the role of procedures and functions in creating a program that is easier to maintain. 3 things. Yes, so to reduce the amount of code, yes, absolutely, that's a perfect example. So yeah, if you've got something to, if you've got something like print, for example, if you had to write the code to print each time you wanted to print, it would be a nightmare, wouldn't it? But yeah, you did know. I did understand it. It did make sense. So let's have a look at the other examples of what they've said. So they divide the program into smaller, more manageable segments, making it more readable, easier to understand, or easier to debug. Procedures and functions with meaningful names. They love that if you mention about meaningful names. So yeah, meaningful names to help provide documentation for the program or to enable, help, or provide abstraction. Procedures and functions may be reused in the program or in other programs. So that's what you said, or run from a single line. Procedures and functions can reduce or eliminate repeated code. So sort of same point really, but just expanded out. So yeah, lots of reasons. Again, that was in your end of year assessment. So well done. Let's look at the next question. We've got a few minutes left. We've got 5 minutes left. We can do some more questions. State what is meant by these data types, integers and real. Again, this was in your exam paper, your end of year assessment. Yeah, it breaks down the program into blocks. Perfect. Yeah. Does that count as a mark? Yes, it would. Yeah. So state what is meant by integer and real and give an example. Yeah, an integer is a whole number. Correct. Good. And yeah, a real is a decimal number. Perfect. Yeah, good. Excellent examples. If we have a look at the mark scheme, whole number, i.e. 26, it's just an example. And then a number that contains a fractional part or decimal place, 18.75 there is their example. Good. Excellent. Okay, next question. Oh, now this is errors in code question. So I think we might leave that because we've only got like 2 or 3 minutes left. And this is going to be a big question. So what I'll do is I'll just leave this up here. And what you might want to do while we, in the next 24 hours, because we come back tomorrow night, is have a look at this code and see if you can find 4 errors in it. And then come back tomorrow and tell me what the errors are for this. Okay. Right, I hope you found that helpful. Don't forget, tomorrow morning is Improve Your Python. We're going to be looking at if statements again, because there's a lot of stuff to do with if statements. And then tomorrow evening at 6 o'clock again, we're going to be doing, we'll do this question and we'll carry on. If you do have any other questions that you want to ask, drop me an email and have a good evening. Bye, everybody.